In this media, you will learn about the working of series voltage regulator. Regulator is used to provide a constant DC output from a variable DC input. In series voltage regulator, the regulating element is connected in series with the load. The constant output is obtained by varying the resistance of the regulating element. The schematic diagram of series voltage regulator is shown. It consists of transistor Q, Zener diode Z, current limiting resistor R, and load resistor R sub L. The transistor is the regulating element which is used to regulate the voltage to the load. The bias voltage of transistor is 0.7 volts. The Zener diode is used to set the fixed reference voltage to the transistor base. Resistor R is used to limit the current through the Zener diode. Assume that the required output voltage is 8.3 volts. The unregulated DC supply of 12 volts is given to the input terminals. Assume that the breakdown voltage of Zener diode is 9 volts. Zener diode starts conducting at 9 volts. This is the reference voltage to the transistor base, which is the fixed value. The output voltage is the voltage difference between the Zener voltage and transistor emitter base voltage, V sub BE. The conducting voltage of transistor is 0.7 volts. So, the voltage drop across the transistor Q is 3.7 volts. The output voltage of 8.3 volts is taken across the load. When the input voltage is increased to 12.2 volts, the voltage across load gets increased momentarily. But Zener diode maintains the constant reference voltage of 9 volts. The bias voltage of transistor becomes less than 0.7 volts. Hence, the resistance across CE terminal of transistor gets increased. The voltage drop across the CE terminal increases and makes the output voltage to 8.3 volts. When the input voltage is decreased to 11.8 volts, the voltage across load gets decreased momentarily. The bias voltage of transistor gets increased above 0.7 volts. But Zener diode maintains the constant base voltage of 9 volts. Hence, the resistance across CE terminal of the transistor gets decreased. The drop across the CE terminal decreases and makes the output voltage to 8.3 volts. Thus, when the input voltage is increased or decreased, the output voltage remains constant. In this exercise, you will learn about the working principle of shunt voltage regulator. The principle of the shunt voltage regulator is explained with a circuit. Shunt regulator always produces a constant DC output voltage from a varying input DC voltage. Shunt voltage regulator circuit comprises of Zener diode Z sub 1, transistor T sub 1, load resistance R sub L, fixed resistance R sub 1, and current limiting resistance R sub 2. The transistor is the regulating element which is used to regulate the voltage to the load. Transistor base is provided with a constant reference voltage by the Zener diode. The Zener diode always maintains the constant voltage of 6 volts. The bias voltage of the transistor is maintained at 0.7 volts. Now consider an unregulated voltage supply of 12 volts is given as the input voltage. The output voltage is assumed to be 6.7 volts. The Zener reference voltage is assumed to be 6 volts. The conducting range of Zener starts only from 6 volts. Hence, 6 volts is the constant voltage fed to the transistor base. The current limiting resistance, R sub 2, is used for limiting the flow of current through the Zener diode. The voltage across R sub 2 is 12 minus 6, or 6 volts. The difference between the voltage of transistor base emitter, V sub BE, and the current limiting resistance, R sub 2, is the voltage of the fixed resistance. The fixed resistance voltage is 5.3 volts. The output voltage is the sum of voltages of the Zener voltage and transistor base emitter voltage V sub BE. The output voltage is calculated as 6.7 volts. Now this output voltage, 6.7 volts, should be attained even if the input voltage is increased or decreased. Assume that the input voltage is increased to 12.1 volts. The current across load gets decreased momentarily. The bias voltage of transistor gets increased to 0.8 volts, which is more than its conducting voltage. The Zener diode always maintains the constant voltage of 6 volts. Due to the increase in the bias voltage of the transistor, the resistance across the CE terminal gets decreased. The decrease in the resistance makes more current to flow through the transistor. The same current flows through the fixed resistance R sub 1, and the voltage drop across the fixed resistance is increased to 5.4 volts. Therefore, the output voltage is decreased to 6.7 volts. Now, assume that the input voltage is decreased to 11.9 volts. The current across load gets increased momentarily. The bias voltage of transistor gets decreased to 0.6 volts, which is less than its conducting voltage. The Zener diode always maintains the constant voltage of 6 volts. Due to the decrease in the bias voltage of the transistor, the resistance across the CE terminal gets increased. The increase in the resistance makes less current to flow through the transistor. The same current flows through the fixed resistance R sub 1, and the voltage across the fixed resistance is decreased to 5.2 volts. Therefore, the output voltage is increased to 6.7 volts. Thus, the output voltage is maintained constant irrespective of the variations in the input voltage.